Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like quadratic equation, remainders, cyclicity, coordinate geometry, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In this video, we are going to see the maximum and minimum value for modulus function and quadratic expressions. So let us start with today's video. Before seeing the maximum and minimum values of a modulus function, let us first see what is a modulus function. So a modulus function can be defined as a function which gives the absolute value of a number or a variable. For example, say if I take x to be 4, then the modulus of x would be simply mod of 4, which would be 4. But if I take x to be say minus 4, in that case mod of x would be mod of minus 4, which would be 4. That is, the absolute value of the number minus 4 or the magnitude of the number minus 4 is 4. In a similar way, if I take x to be say minus 3.5, in that case, mod of x would be simply mod of minus 3.5, which would be 3.5. So that means the outcome of the modulus function will always give us a positive number, no matter what is the input to this function. So modulus of a function x can be defined as x when x is greater than or equal to 0. And it will be defined as minus x when x is less than 0. We can verify this by taking some more examples. For example, say if I take x to be minus 17. So according to the definition, mod of x would be minus x when x is less than 0. So in this case, mod of x would be minus of x. So this would be minus of minus 17, which would be 17. In a similar way, if x is 17, in that case, mod of x would be simply x. So this would be simply 17. So a modulus function is a function which gives us the absolute value of a number or a variable, and the output of this function is always positive no matter what is the input. Now, let us consider this modulus function mod of 3x minus 5, and let us see the maximum and minimum value of this function. Well, before proceeding with mod of 3x minus 5, let us consider first 3x minus 5 and let us see how it behaves. Let us assume 3x minus 5 is equal to y. So that means for different values of x, we'll be getting different values of y. Now, y equal to 3x minus 5 represents an equation of a line with some slope and with some x and y intercepts. Well, I have already covered the equation of a line, slopes, x and y intercepts, etc. concepts in the coordinate geometry videos. So if you're not familiar with these concepts, you can go through those videos which has already been uploaded, the link of which I have given above and also in the description box. So now, if you plot this line in x and y coordinate axis, we'll be getting a line which looks something like this, where this is the x-intercept and this is the y-intercept. To find the x-intercept, we can simply put y to be 0, which will give us x to be 5 by 3. In a similar way, to get the y-intercept, we can put x to be 0. In that case, y would be minus 5. So this point would be minus 5 and this point would be 5 by 3. Now, from this line graph, we can see one thing, that is for x greater than 5 by 3, y is always taking a positive value, and for x less than 5 by 3, y is taking a negative value. So if we consider mod of 3x minus 5 instead of 3x minus 5, in that case, all the negative values of y will become positive values. So in that case, the graph would be something like this, that is of a V shape. For example, say when x is 1, in that case 3x minus 5 would have given us 3 into 1 minus 5, that is minus 2. But mod of 3x minus 5 would have given us mod of minus 2, that is plus 2. So at x equals to 1, say somewhere here, the negative value of minus 2 would have become positive value as 2. In a similar way, at x equal to 0, 3x minus 5 would have given us a value of minus 5, whereas mod of 3x minus 5 would have given us a value of mod of minus 5, that is plus 5. So that means this minus 5 would have become plus 5 and so on. So that means all these negative values of y would have converted to positive values of the same magnitude. So the graph of 3x minus 5 would be of a V shape and it will attain a minimum value at some point. From the graph, we can see that the minima point, that is the point at which mod of 3x minus 5 attains a minimum value, is x equal to 5 by 3. And the minimum value that this graph attains is simply 0, because at x equal to 5 by 3, y is 0. So such kind of modulus function will always have a minimum value of 0, and we can get the minima point simply by equating this part to be 0 and finding the value of x. So if we generalize this and consider a generic modulus function as ax plus b, in that case we can say that this modulus function will always have a minimum value of 0, and it will have the minima point simply at ax plus b to be 0, that is at x equal to minus b by a. So for modulus function ax plus b, it will always have a minimum value of 0, and the point at which it will attain a minimum value would be simply x equal to minus b by a. In a similar way, if the modulus function is of the form of minus mod of ax plus b, in that case the graph would be the mirror image of this graph, that is something like this. So in that case, this modulus function will always attain a value which would be less than or equal to 0. So in such cases, the modulus function will attain a maximum value of 0, and the point at which it will attain the maximum value would be the same, that is at x equal to minus b by a. So if the modulus function is of the form of mod of ax plus b, in that case it will attain a minimum value of 0 at x equal to minus b by a, whereas if the modulus function is of the form of minus mod of ax plus b, in that case it will attain a maximum value of 0 at x equal to minus b by a. Now let us do some questions to find the maximum minimum value of a modulus expression to understand it more clearly. So here the question is, find the maximum or minimum value of the following modulus expressions and also find the value of x at which the maximum or minimum value occurs. Let us start with the first one. So here the expression is 6 plus mod of 2x minus 3. We know that 6 is a constant and we are adding some number to it. And we also know that mod of this will always attain a value which would be greater than or equal to 0. So we can say that this complete expression will have a minimum value, and the minimum value would be simply 6 plus 0, that is 6, because this mod of 2x minus 3 will have the minimum value 0, and the point at which this minimum value will occur would be simply 2x minus 3 equal to 0, that is x equal to 3 by 2. So the minimum value for this expression is 6, and the point at which it occurs is x equal to 3 by 2. In a similar way, for this expression 8 minus mod of 3x minus 4, we are subtracting a positive quantity from this constant 8. So we can say that this expression will attain a maximum value, and it will attain a maximum value when we are subtracting the minimum value from this constant 8. And we know that mod of 3x minus 4 will attain a minimum value of 0 at 3x minus 4 equal to 0, that is at x equal to 4 by 3. So the maximum value that this expression will attain would be simply 8 minus 0, that is 8, and the point at which it will attain the maximum value would be simply x equal to 4 by 3. Now let us see the maximum minimum values of a quadratic expression. The generic form of a quadratic expression is given by y equal to ax square plus bx plus c, where ABC has some constants and a is a leading coefficient and a is not equal to 0. So if the leading coefficient a is greater than 0, in that case we'll be getting an upward parabola, that is something like this. So we'll be getting a minima point and we'll be getting the minimum value. So the minima point is given by x equal to minus b by 2a, and when we put this x equal to minus b by 2a in this expression, we will be getting the minimum value. In a similar way, if the leading coefficient is less than 0, we'll be getting a downward parabola, that is something like this. So we'll be getting a maxima point and we'll be getting the maximum value. The maxima point is given by x equal to minus b by 2a, and again when we put this x equal to minus b by 2a in this quadratic expression, we'll be getting the maximum value. Now when we put this x equal to minus b by 2a in this quadratic equation, in that case the maximum or the minimum value will be given by minus of b square minus 4ac upon 4a, which would be minus d upon 4a, where d is the discriminant and it is given by b square minus 4ac. Well, I have already covered the maxima minima part of a quadratic equation in a more detailed way in the quadratic equation video. So if you want to know where these points are coming from, you can refer to that video, the link of which I have given above and also in the description box. Now let us see this question to find the maximum and minimum value of the following quadratic expression and also the point at which the maximum and the minimum value occurs. The first quadratic expression is 2x square plus 3x minus 4. Here the leading coefficient a is greater than 0, so this will give us an upward parabola. So we'll be having minima point and we'll be getting minimum value. So the minima point would be simply given by x equal to minus b upon 2a. Here the value of b is 3 and the value of a is 2. So the value of minus b upon 2a would be simply minus 3 upon 2 into 2, that is 4. So this would be minus 3 by 4. So the point at which this quadratic expression will attain its minimum value would be simply x equal to minus 3 by 4. And we know that the minimum value would be simply given by minus of discriminant upon 4a. So here the discriminant value would be simply b square minus 4ac. So that would be 3 square minus 4 into 2 into minus 4, as the constant value c would be minus 4. So if we simplify this, this would be 9 plus of 32, so that would be 41. So the minimum value would be simply minus 41 upon 4 into 2, so that would be minus 41 by 8. So the minima point is minus 3 by 4 and the minimum value is minus 41 by 8. In a similar way, for the second quadratic expression, we have the leading coefficient a less than 0. So we'll be getting a downward parabola. So we'll be having the maxima point and the maximum value. Again, the maxima point would be given by minus b upon 2a, and that would be minus 2 upon 2 into minus 4, which would be 1 by 4. And the maximum value would be again minus d upon 4. So here the discriminant value would be again b square minus 4ac, which would be 2 square minus 4 into minus 4 into 1. So that would be 4 plus 16, that is 20. So the maximum value would be simply minus 20 upon 4 into minus 4, which would be 5 by 4. So for this quadratic expression, the maxima point, that is the point at which this quadratic expression will attain its maximum value, would be 1 by 4, and the maximum value would be simply 5 by 4. So we can simply use x equal to minus b upon 2a to find the maximum or minima point, and minus d upon 4a to find the maximum or minimum value of a quadratic expression. So that's it for today's video, in which we have seen how we can find the maximum and minimum value of a modulus function and quadratic expressions. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.